experiment 26. It involves titration curves of polyprotic acids. This experiment has two sessions. There are two parts in the experiment. We have the part A and the part B. The part A is on standardization of sodium hydroxide solution. Part B is on determination of acid dissociation constants and the molarity of the unknown acid. I proceed with the experiment. I will introduce you to the apparatus and chemicals that will be used for this experiment. We have here the potassium hydrogen phthalate. That's the potassium hydrogen phthalate. We have the sodium hydroxide. We have the polyprotic acid, and we have the phenolphthalein serving as the indicator. We have the pH meter, the burette, and other. We have the conical flask, beakers. Those are the glasswares that will be used for the experiment. Meanwhile, if you want to carry out this experiment, there are precautions that you need to take. First, in the first part, which involves the standardization of sodium hydroxide solution, you will make use of potassium hydrogen phthalate, which you are going to ensure that when you want to take the sample, you take it appropriately. Second, your sodium hydroxide solution, make sure that you check the label properly and ensure that it is what? Sodium hydroxide. While on the use of the pH meter, if you want to make use of the pH meter, first of all, ensure that the pH meter is well set. You calibrate it and ensure that you don't expose the bulb of the electrode. Ensure that the pH meter, make sure you use a buffer. You can use buffer 7, you can use buffer 4, depending on you. There's buffer 7, buffer 4, buffer 10, just to ensure that you calibrate the pH meter. So make sure that all the apparatus that will be used for the experiment is in good condition. With the A part of the experiment, which involves standardization of sodium hydroxide solution. First, the weigh KHP 0.4 gram. The 0.4 gram of KHP, our KHP is potassium hydrogen phthalate. So you can see we have the 0.4 gram of KHP in the conical flask. That's 0.4 gram of the KHP in the conical flask. Add 100 ml of distilled water. You add 100 ml of distilled water. You can see how I'm adding. I am gently. You don't add everything at once. Add little and swirl continuously. Swirl continuously. Ensure that every particles dissolve. You can see. So whenever you want to dissolve material and you are given a specific volume of solvents to be added, don't add all the solvents at once. First of all, add few volume of the solvent and you then add the other. So you can see I added a few volume of the distilled water, then into the KHP swelling to ensure that every particle dissolve. Then you can see dissolve. You add again the remaining distilled water. And you swell again, swell properly to have homogeneous solution. You can see, remember that KHP is an acid. It's an acid and is a primary standard. That is why it is being used to standardize sodium hydroxide. You see, swell properly, So after that, I add my phenolphthalein, 2 drops. But make sure when you want to add your phenolphthalein, don't dip this directly into the container. Take little of the material of the liquid substance, okay, you can see, take little into this. The essence of doing this is that you will not contaminate this particular one. So you just take little from this into another container, as I've taken that into another beaker. So it's where I will be taking my drops. You can see, okay, just 2 drops. 2 drops, carefully. 1, 2. That's your phenolphthalein added. Okay. Swell very well. Then we already have our sodium hydroxide solution in the burette. And see, the sodium hydroxide solution in the burette. You take the initial reading from the burette. When if some students are short, they cannot see. If you can't see, just bring it down a little bit to take the reading. This is initial burette reading here is 1.5. 1.5. Run gently until we'll observe a pale pink color. When you are running, be careful, don't run too fast. Make it slowly, so that if there is any color change, you can easily stop. When you run, you swell. You can see you're closer to the end point. That is why the color will disappear. You see that when the color is permanent, the pink is pale pink is permanent. That's the end point. Now that's the end point. You see the color of the pale pink. The burette reading, this is 24. To obtain this, you have to repeat the experiment with 2 more sets. Means you weigh another 0.4 gram. You add 100 ml of water and repeat the titration. So you do it 2 more times so that you can have 3 sets. So from there you can get your titer value. Thank you.
We will move on part B. So part B, it is determination of the acid dissociation constant and the molarity of an unknown acid. For this one, we will use a beaker of this size, 150 ml. And first of all, what you need to do is you need to measure 25 ml of the unknown acid. Unknown acid is a polyprotic acid, and you need to take 25 ml from this one. So before that, since this container is large and it is difficult to handle, better you transfer this one into a beaker of this size. Okay. Then you can measure 25 ml of the unknown into a measuring cylinder. Okay, at the very end you can use a dropper. To have an accurate volume of 25 ml. So make sure the lower meniscus of the liquid aligns with the 25 ml mark. Okay, so 25 ml of the unknown has been measured, and this one you pour into the beaker. Okay, we have measured 25 ml of the unknown into 150 ml beaker. And then before you start, what you need to do is you need to get the initial reading, initial pH of the solution of the unknown acid. Right. So you get the electrode. Before you insert into the unknown, make sure you wash the bulb of the electrode and make sure it is clean and dry. And then you immerse fully. Make sure the bulb is inside this liquid, like fully immersed, and then the pH is you need to wait until it gives a stable reading and then record it. Okay, so the next step is you need to add exactly 1 ml of sodium hydroxide, which you standardized in the previous step. You need to add using a burette because that is accurate up to 2 decimal, right? Then you need to add exactly 1 ml of sodium hydroxide into the unknown polyprotic acid. Make sure you do this step cautiously since you don't want to add more than 1 ml. It should be exactly 1.00. So we have added 1 ml of the sodium hydroxide solution, which then what you need to do is you need to mix the solution under magnetic stirring so that you will have a homogeneous solution. So mix the solution under magnetic stirring, and the next step would be measure the pH using the pH meter. Okay, so likewise, get the electrode, make sure the bulb is clean, and you just immerse fully until you get a stable reading. And once you get a stable reading, just note down the pH value. Already added 1 ml of the sodium solution into the unknown, and we just measure the pH of the final solution, and then you need to add like 1 ml more and repeat the same steps as we did before. So use the burette to add 1 ml of sodium hydroxide. Once you have added 1 ml of the sodium hydroxide solution, you mix the solution under magnetic stirring to get a homogeneous solution. Okay, once you finish with the magnetic stirring, the next step would be before measure the pH of the solution, right? So make sure you wipe the bulb of the electrode and make sure it is clean, immerse fully, and then wait until you get a stable pH reading. We have added 2 ml of sodium solution into the unknown polychloric acid. So likewise, you continue adding 1 ml until you have added 25 ml of the sodium solution. So at each 1 ml interval, you need to measure the pH and get the stable reading and record until you have added 25 ml. If you have added 25 ml, you need to add 2 ml each. At 2 ml each addition, you measure the pH until the pH reaches 12. So in this case, after it reaches 25 ml, you need to measure the pH or get the pH reading at 2 ml addition of NaOH until the pH recorded is 12. So in this case, we have added the NaOH solution until the pH has reached around pH 12. So as you can see, the value is 12.05.